Welcome back to Math 109 Plane Trigonometry. In this video we're going to take a look at the idea of reference angles and how we can use what we learned in section 2.1 about the right triangle definitions of the trigonometric functions to obtain the trigonometric functions of any angle. So, we'll start with the coordinate plane. The definition of a reference angle is the smallest angle between the terminal side of the angle and the x-axis. Easy way to remember this is if I draw a bow tie shape here. The angles on the inside of that bow tie are going to be your reference angles. And in our textbook, they refer to the reference angle as theta prime. So theta prime is equal to our reference angle. You may also see, from time to time, me use the variable alpha for a reference angle. So you might see that as well. So using these definitions, we can take a look at the four different possibilities for what theta prime is. First things first, we're going to go ahead and reduce everything to being between 0 and 360. So we'll use coterminal angles to get there. That would mean in the first quadrant, our reference angle is simply the angle, theta. In the second quadrant, going all the way around to the negative x-axis is going to be 180 degrees. So we need to subtract off the portion only going to the terminal edge. So that's going to be 180 minus theta. Now if I go to the third quadrant, so we've got to go all the way around to 180 degrees and then add on at theta prime, which would mean theta prime is equal to theta minus 180 degrees. And finally, in the fourth quadrant, going all the way around gives us 360 degrees. So if we subtract off the portion that gets us to that terminal side, that's going to make the reference angle there 360 minus theta. Now the nice thing that we have with reference angles is that it is always true the sine of theta prime is equal to the absolute value of the sine of theta. And that's true for any angle. It also turns out this is true for any of the trig functions. So I'll put it down explicitly for cosine. Because then we can use the identities from section 1.4 in order to obtain the other trig functions, and thereby obtain that the absolute value of the trig functions are always equal to the trig function of the reference angle. So in the next video, we're going to take a look at some examples of how to work with reference angles.